Thank you. All right. Now can you hear me and see me? Thank you so much for calling that out. And again, since no one heard anything I was saying, I was going to say we're going to get started in just a minute. So thank you, Alejandro, for calling out that my speaker wasn't working. My mic got unplugged. I've been having a little issues, so like it didn't physically get unplugged, but the computer kicked it off for some reason. So hopefully, if it does happen during the talk, please let me know as well, and I'll switch microphones. And again, for everyone joining, we'll get started here in just a minute. But I was going to say, if you, since you missed it earlier, if you want to introduce yourself in the chat, maybe tell us a little bit about why you're interested in, computer vision models or ML monitoring. Do you have any models in production? Are you building an interesting project, even if it's just a fun side project? Let us know in the chat. You could also put in where you're watching from. It's kind of fun to see where everyone's watching from as well, since usually like people are all around the world. And, all right, I'm going to go ahead and go into the slideshow mode. And I forget if I was cut off for this earlier, but all the links to follow along with everything is in the description below. So if you're on YouTube or LinkedIn, you can expand that description. We're going to go through just a little bit of slides, and then we will mostly be doing hands-on. So we'll train a computer vision model on a custom data set. So hopefully like you could take what you're going to learn at this workshop, get your own data set, train a model, and then also learn how to monitor it in production. And I'll share these links real quick before we get going. Again, they are in the description, and I'll go over setup a little bit more when we get there. But the only thing you'll probably need to really do is create a free YLabs account. There's no card or anything required, so it should be very easy for you to do. And then the second thing is here's a Colab notebook. So this is what we're going to run the code from. Again, we'll talk more about these things in a minute, but those are just probably going to be the two things you need. You need a Google account to run the Colab notebook. Probably most people already have a Google account. All right, let's get going. Someone said the notebook looks like a broken link. Man, I'm just failing all over the place today. Let me test this out. Also, can anyone else confirm, did it not work for them? Make sure if I have sharing on. It is working for me even in incognito tab, and it's the same link I have used. Let me share the full length URL. I think occasionally there's something weird with Colab. I'll have to look into this. So I shared a link in the chat. Or try removing that weird part that says like auth user equal 1, and maybe it will work. Also, if anyone else in the chat wants to open up that notebook already, I know we're not quite there running the code, but if you just wanted to let me know if it works, that'd be great. Otherwise, we'll get to the link again in a little bit when we actually want to run the code. So if it's not working right now, don't worry, we can figure it out in a little bit. But I'm going to get going through the slides, and then just let me know if it's still not working. So just a quick intro of what this workshop is. Hopefully it's a super friendly introduction to building and monitoring computer vision models with TensorFlow/Keras. And then we're going to use YLabs for the monitoring side. We have an open source project called YLogs as well that we'll be using. And this is kind of designed with no previous experience expected, but definitely knowing some Python and machine learning concepts could be helpful. And there's a lot going on with computer vision models, so it might seem complicated to you depending on what you've already learned. Don't worry, we can go through it. You can still run all the code, and I'll try to describe everything that's happening in the code. And then feel free to ask questions. So as we go, I'll be trying to keep an eye on chat. If I miss a question, just ask it again, and I'll get back to you. And keep in mind, you can't learn everything in about the hour and a half that we're going to go through. So some of this could feel really fast-paced or challenging. That's okay, but I think it's fun. We'll go through. We'll do a lot together in that hour. And then obviously you just want to keep learning after the workshop. If you're not familiar with computer vision concepts, etc. A quick introduction. I'm Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. We build tools around AI and data observability. So we'll see one of those in action today, where we can, see some sort of issue with our data or our models in production, and then kind of very quickly be able to troubleshoot that. And hopefully, depending on what your model is doing, it could be very costly if a model is making wrong predictions. So it's a good way of seeing that very quickly, and then you can fix it. And for over a decade, I've worked in software, machine learning, and hardware, mostly with startups and some agencies around Seattle and also Central Florida. And in general, I love making things with technology and like doing some hobby like electronics and robotics stuff, which is really fun. So if anyone wants to mention, or if anyone wants to talk about robotics later, always feel free to stay connected. And yeah, someone said they were able to access the notebook once they removed that auth user at the end. It's weird. I've only seen this very occasionally. Most people seem to be able to access it, but I'll share the link again without that auth user, and hopefully it'll work for everyone. But if you are watching this later or something and somehow you get that link, try removing the code that's after that question mark where it says auth user 1 on the Colab notebook. All right, so a little bit about you. I saw some more people joined. If you want to put in the chat, where are you watching from? Why are you interested in computer vision? Again, if you have any models, whether that's just like a toy side project or anything actually in production, let us know. And then also you can stay connected in the Robust and Responsible AI Slack. So again, link is in the description, but that's going to be a good place to introduce yourself, stay connected with me. So if you have any questions after this workshop, like you're using your own data set or you're actually deploying a computer vision model somewhere and you want to set up monitoring in your infrastructure, that's going to be a good place to ask me, but also it's fun to stay connected with other people in there. So again, a quick setup. You probably already have a Google account. So again, if you just haven't already, go ahead and create a YLabs account. Again, it's free. There's no card or anything required. It should be very quick. I think you just verify your email once you sign up, and you should be good to go. And that's probably the only thing you really need to set up before we get into the Colab notebook a little bit later. And we're going to be using Colab notebook. If you're not familiar with that, that's kind of Google's way of hosting a Jupyter notebook in Google Drive, but it gives you a whole little Ubuntu instance, and we'll look at this later when we get to that part. And then we're going to use TensorFlow, and specifically we're going to use the Keras API in TensorFlow that just kind of makes it easier to build models, deep learning models. And today we're going to use a computer vision model. And then we're going to use YLogs, which is an open source library that we maintain, and it creates statistical summaries of your data. We'll see this in action when we get to the code as well, and then we'll send those summaries to YLabs to understand how to monitor them over time and catch issues with our computer vision model. So real quick, what is TensorFlow/Keras? Also in the chat, has anyone used TensorFlow or Keras before? Or has anyone done any deep learning? Maybe you've used PyTorch, which is the other popular deep learning library. TensorFlow is really popular in deep learning, computer vision, which computer vision often is deep learning these days. There are other things you can do that doesn't involve deep learning, but most of the time if you see a computer vision model in production somewhere like Amazon Go or self-driving car, it's going to be using deep learning under the hood. What's really cool too is we can use something called transfer learning, which we'll use today, where we're going to take a pre-trained model trained on a whole bunch of different data, and then we're going to fine-tune that model on our own data set. So we'll actually see just in a few cycles of looking at our data, our model is actually going to be able to learn pretty good about what we're looking for. TensorFlow is really great because one, it's a fairly easy to use deep learning package, and it has a really good deployment ecosystem. So some people, are always asked the question like, what's better, PyTorch or TensorFlow? I really like them both, but TensorFlow does have really good deployment features that I think PyTorch is catching up to right now. So like, it's easy to deploy on mobile and edge. They have a TFX, which is like a way to serve your TensorFlow models very easily. And then, TensorFlow JS, so you can actually run models in the browser, which is really cool as well. And there's other frameworks you can use with PyTorch and stuff to help optimize your model for these situations as well. But TensorFlow does a really good job of it. So again, let me know in the chat, has anyone used TensorFlow before? And then let's talk quickly about what is ML monitoring. And I think I mentioned at the beginning, we're just going through a few slides. This won't take too long, and then we'll get to the hands-on part. So what is ML monitoring? ML monitoring is the collection of statistics or data That could be like performance data, metrics, different types of metrics from parts of your ML system. So you're typically going to have some sort of production pipeline. You might have all sorts of different stuff in there, like transforms on your data. You might be pulling data in, doing a transform on it, and then running that transform data into the model to make a prediction. And you want to be able to collect statistics or data from that pipeline where you think you want to be looking, like where there could be some sort of issue. So there's just like a high level view where you have your environment, where you could be doing all the fun machine learning stuff. You're going to be collecting some sort of AI telemetry. Here, we're going to use YLogs to do that. And then we're going to pass that telemetry to a system where we're able to kind of monitor that over time and detect anomalies or any changes. And then you can use those actions or you can use that data to take action. So you might do some sort of automated trigger. So if data drifts, we'll talk again more about this in a minute, but if the data distribution changes a lot in production, maybe you're going to kick off some sort of automated crowdsourced annotation job and then use that annotated data to get performance metrics, and then maybe also use that annotated data, since you already have it, to retrain a model, put that new model in production, and then compare performance between those two models. It's a very kind of common loop that you're going to build into your production ML environment. So why is it important? I touched on it a little bit, I think, but we have a saying: bad data happens to good models. So you can spend all the time you want training your model and using evaluation data sets on it. Chances are, though, once you put in production, it's going to encounter things that weren't in the training data set. And especially, this is true for most types of models, but computer vision, there's so many different variations of things that you might be looking for with pixels and images that you'll most certainly see something like this. So you might experience data quality issues, data drift, concept drift, bias in your models. You might want to use something like explainability to understand why your model is making predictions. All these can be used together to kind of really robustly observe your AI application. And we'll talk more about these in a little bit as well. But has anyone ever put a model in production, even if it wasn't for work, like you had some sort of toy project? Have you put a model somewhere and then experienced like behavior that you weren't expecting? Or did it not perform well on like a certain type of piece of data that you thought maybe it should have? So just a couple examples of data quality issues for computer vision. You're often collecting images from somewhere or a video stream. That could be directly from the camera. It could be from someone uploading an image. But typically, like if you're collecting something right off a video stream, you see all sorts of different stuff that happens in the world of like someone might accidentally hit the camera and it changes direction, or the camera dies or it starts having issues and there's like pixels in it now that weren't there before, or something that is kind of funny, but I feel like a lot of people experience this. If you put a camera out in production somewhere, even if it's a somewhat controlled environment like a manufacturing floor where you expect, there's not going to be natural lighting changes or anything like that, someone is probably going to turn off a light, or a light bulb's going to die at some point, and then you're going to get really probably darker image returned that your model wasn't trained on, and it might be too dark to even see anything in there anyway, which is interesting. So if any of these things happened, you would want to be able to catch that as quickly as possible. Otherwise, maybe your model's running for days or something like that and not giving you any good predictions for your business. A quick example of data drift. So this is usually where the distribution of your data coming in production no longer really closely matches the distribution of the data that your model was trained on. So the input data changed here. And in computer vision, you might see a lot of this with like seasonality. Maybe I trained a computer vision model to detect sheep, and all of the training data had sheep on green grass. They're in a pasture, but now it's winter, and now maybe the sheep are on a white background because there's snow. So it was a big shift of like there used to be all these green pixels, and I was like looking at sheep. Now there's all these white pixels, and in that case, the sheep might blend into the snow as well. So you'd want to take this new data, retrain your model with that to account for this kind of seasonality drift that might happen. Same with the lighting, and there could be all sorts of numerous things. Has anyone experienced some sort of data drift before? If you've ever put a model in production, you probably have. A quick example of concept drift, similar to data drift, except for your your model outputs are no longer really mapping to what you're expecting in the real world. So I often use the housing market as an example. Like if you trained a model, it could even be a computer vision model in this case, if you fed it images to classify how much the house would cost just based on images or something like that. If you trained this model like 5 years ago, the prices would be very different than what they are now. So you'd want to update the output you're expecting and then retrain your model. And then there's other areas of data and ML monitoring, like I kind of touched on, like model explainability, bias and segmentation. And we're not really going to go hands-on for those in this workshop, but there's a lot of really cool tools for it. Actually, this image is a feature built into Keras today. I thought I had the link, but I guess I forgot it. That allows you to kind of take that computer vision model you trained and then understand what parts of it are making it predict, in this case, like why is it predicting elephants? All right, so enough slides, and I'll paste the links again, and we'll get ready to do the hands-on part. And then for anyone just joined too, if you want to say hello in the chat, that's always great. Oh, also, does anyone else, can anyone else let me know too, you were able to get the Colab notebook working? So someone said if you just joined in here, if you follow that link, maybe you'll get some weird access thing. If you remove that text after the question mark at the end of the URL, the auth user equal 1, apparently it should work. And it's interesting, some people are getting that this time. And again, if you haven't signed up yet for YLabs, you can do so here. And then as we're getting set up, so because we're getting into the hands-on part, and I see some other people just joined, if you do join a little bit later and the slide's gone, all the links to everything is in the description below. So you should be able to open them up and follow along. And I'll also just mention real quick, so if you want to fill out this small survey for a chance to win some swag, which actually we have new shirts. We have these No More ML Oops shirts, which are really fun. If you can fill out that form, and we'll enter in kind of a raffle where we'll select like 5 people from this workshop and send them some swag. And I will also quickly mention, if you want to help us try new features, we have some really cool new features coming out with YLogs, our open source library, and we'd love for people to give us feedback. There's a form to fill here as well if you want to provide us early feedback. And I'll give everyone a second to open up those links, especially that YLabs sign-up one and that Colab notebook. And while you're doing that, I'm just going to paste these links again on the LinkedIn stream because I don't think they're over there yet. So give me 1 second. Again, these top 2 are the most important for just the following along part. And this last form, if you want to give us feedback on new features, be some of the first people to try them. I think it's really exciting. I'm really excited about it. All right. So I'm going to go. This is our notebook. You should be able to open it up. And again, if somebody wants to let me know they were able to, that'd be great. And I'll share the link one more time without that auth user at the end, because it seems like that might be causing the issue. All right. Anyone in the chat just want to let me know you were able to open that up, and then we should be able to kind of run all the code in here. And I'll go ahead and get started. So I'm actually going to make a copy, and you want to do this as well. So you can make your very own copy of this notebook, and you can do any changes you want to it at this point. And don't worry about breaking it. So I always love, playing with code, see what happens. Save a copy using this file, save a copy in Drive, and then you can bookmark this URL if you want to always come back to it and fork it again. So go to save a copy in Drive, and it should just take a few seconds to open up a new copy in a tab. Open in tab. Sometimes you get this pop-up, sometimes you don't. All right, so now this is your own notebook if you've saved your own copy, and you'll be able to run all the code here. And like I said, also make changes. And so you might want to take this copy and use your own data set later and train a computer vision model that way. So let's run this first code cell. So Jupyter notebooks or Colab notebooks are a way of kind of combining text and code and visualizations and outputs all in one place. It's really neat if you've never used them before. Very popular tool in data science and computer vision or in machine learning. To run a code cell, you can hit this little play button on it. And the first time you run the cell, it's going to take a few seconds because it's actually spinning up a separate instance for us here. So you can see it's initializing, and now for me it's connected. Again, it can vary on speed, but it should just take you a few seconds to kind of spin up your own little cluster here. And I'll also quickly note, so if you go to Runtime, change runtime type, you don't need to do this, but we are using a GPU. It gives you a lot of free GPU hours, which is pretty cool because we need a GPU to kind of quickly train computer vision models. So if you're getting started in deep learning or computer vision, Colab's a really cool way to get started without having to have your own GPU at home. So now we ran this code cell, and you can also run it by hitting ShiftEnter, which is often how I run it. So you might not see me clicking that play button. That's me hitting ShiftEnter, and then it moves to the next cell, and then you can hit ShiftEnter again, it runs that cell, and you hit ShiftEnter again. So that's often kind of how I'll be running it in this workshop. First thing we want to do is pip install YLogs with YLabs dependencies because we're going to be writing these profiles over. Again, we'll talk more about YLogs in a second here. Just make sure this installs, and I think we're going to actually be good to go. Sometimes there's a dependency thing in Colab specifically where we have to uninstall a version of the library. Let's see, because it comes pre-installed with a whole bunch of the popular machine learning libraries. So occasionally there might be a conflicting one, and then you just have to restart runtime. But we didn't get that message today, so they probably updated the version of Pillow, which is how we read in images here. But if we do get this error later, we'll go to runtime and hit restart runtime. But I guess we're going to be good now. All right, so data monitoring with YLogs. YLogs, again, is an open source library. You can log data pretty much of any time, of any type. We have a lot of cool features around images specifically and embeddings. So if you want to use this in like NLP applications, large language models, computer vision, your tabular data, you can use YLogs for it. And again, you can check out the repo here. I'll share the link. Again, it should be in the description as well. But there's a lot of examples. So if you go to this Python folder and then the example folder in there, you'll find a whole bunch of examples. And one cool thing about it is it integrates with most probably libraries and pipelines that you might be using in your machine learning application. And if you can run it in a Python environment, you can use it almost anywhere where you have a Python environment. So with YLogs, what it does, and we'll see it in action in a second, but it creates these profiles of your data. So you're going to pass in your full data set. In this case, it's going to be images. And then we're going to collect some statistics about it. So we have some image stats we're going to collect. But if you're doing like tabular data, like the iris data set with the petal length and width, you're going to pass in that data set. And then it's going to extract some aggregate features. So you can think of like the mean, the max, the min, etc. It's a little bit more fancy than that. But just with these kind of statistical features, you can actually do a lot, pretty much all the use cases that you would need for machine learning or data monitoring. And what's also really cool about that is it doesn't contain your raw data. So it's just a summary of your data set, and that makes it really efficient or lightweight. So you can pass these very cost effectively across like an edge device or just your Python environment to YLabs. And then they're customizable, and the profiles are mergeable as well. And so let's see what this looks like. We'll see what it looks like in a minute. Just want to prep it up, and then we'll go ahead and install TensorFlow or start using TensorFlow, and then we'll look at a profile of images in a second. So let's go ahead and do our imports. We're using TensorFlow. We're doing using Keras, which is the API layer, to make it a little bit easier to create a model. We're importing YLogs, and we're specifically also importing this log image function. This is going to allow us to quickly extract features from our images that we're going to use for ML monitoring. And then we're going to import YLabs writer. So we're going to take those logs of images, those statistical fingerprints of your data, and then pass those to YLabs for monitoring. And again, we'll see all what this looks like in a minute. All right, and then one last piece of setup here. And I did not comment out this part. So if you're following along here, either delete this text above or comment it out, and you can quickly comment multiple lines of code by highlighting and then hitting Command or Control /. So again, you can just delete that top line of code. Sorry, I accidentally uncommented, I guess. So we're going to get our API key, our org ID, and model ID real quick from YLabs. So if you signed up, you should be able to get into YLabs, and it should look something like this. You will have probably some different starter projects in here. So what we want to do, though, is go ahead and create a new project. So you can click this Create Project button, and it's going to bring up a little screen like this. We're going to set up our own model, so click Set Up Model. And then we have to give it a model name. I'll just call this CV Workshop, but you can give it any name you want. And then we're going to define this as a classification model. You can see that you can use this in all sorts of different data resources or different types of models. Classification model is what we're going to select here. This just helps us to kind of take those metrics that we want to do to calculate like performance, and those will be displayed here accurately as a classification model. But you can select like a regression model or different other types of models depending on what you're going to use like in your application. But today we're using a classification model. Then hit that little add model, and then we'll see these numbers by our models. And so mine is model 177. Yours would probably be like 0 or 1, 2, or 3 if you're just starting out with YLabs. So I'm going to take this model number, go back to my notebook, and I'm going to paste it into this model ID area. Make sure that if you accidentally copy over any space or new line characters or anything like that, that you get rid of those. And so it's just a string with no space. So I'm going to go back to YLabs. From the same screen, we're just going to hit this little tab over here, Access Tokens. We're going to create a new API token. So again, I'll just call this CV Workshop. It doesn't really matter too much on the name. We'll hit Create Access Token, and then we get this token up here. I'm going to hit Copy. We're going to go over here, copy it into our API key area. Again, make sure you don't accidentally have any spaces or anything like that. One last thing, org ID, same screen. It's in multiple places here. You can see the org ID is here. I'm going to go ahead and copy it. It's also listed here. So I'll copy this into org ID, and again, make sure there's no new line or spaces or anything like that. And then run this, and we should be good to go to just run the rest of the code cells. But real quick, just want to take a quick second. I know there's a little delay from me streaming. Was everyone able to get those values, like the model ID, the API key, the org ID? Let me know if you want to have me go through it again for any of those specific values. And there's kind of some instructions here too if you expand this. Shows you where to look for them. But I'm going to pause just for a minute or a few seconds if anyone has any questions about them. And if there's no questions, I'm going to assume everyone got them flawlessly. All right, I'll keep going. And again, if you need me to come back and cover something, let me know. All right, so let's go ahead and download our data set that we're going to use. This is just a small little image data set that I stored on my GitHub. And if we list all the items in there, we can see that there's two folders, one called Pi and Jetson classification data set, and then there's also one called sample data. That sample data came with Colab, and this folder contains the data that we want to train our model on. So here we can look in, and we see there's 3 folders. We'll look at what the data looks like in a minute, but we have days, we have a training data set, and a validation data set. So in deep learning, typically you train your model on the training data set, and then you want to see how that model is learning. So you'll look at the results on a validation data set that it's not actually learning from, but it's making predictions on, so you can see how well it's doing on new data that's not actually in the data set. And then the days folder we're going to use to kind of simulate our model in production and loop through those days as if it was in production, so we'll have like 7 days of data. So let's go ahead and generate a data set. In TensorFlow, you can use this processing function where it actually looks for images in a directory. So all we do is we're going to pass it that training path, which, by the way, if you ever want to explore the files visually, you can also open up this little folder icon, and we can see that we have those folders that we just looked at. So we have the path where it's looking for into that Pi and Jetson folder, and then looking for the images in train specifically. And then we're setting the image size, so it's going to read them in by 180, 180. And then batch size is 10, so it's going to read in 10 at a time, basically, when we're training our model. And then we're doing the same thing for a validation data set. And so this is really small. This is going to work great for our kind of toy project today, but typically you'd probably have way more images. In this case, we're only going to be training on 68 images with 2 classes, and then we're going to be validating on 10 images. But will actually work pretty good for our use case today. So let's look at the data real quick. We can see that these are images of a Jetson Nano and a Raspberry Pi. If you're not familiar with those, they're kind of small little computers. I like to use them in like robotic projects, so I have a whole bunch around in my house that I just took photos of. So the Jetson Nano is this like darker colored board, and the Raspberry Pi is this green colored one. You can see that the Jetson is class 0 and the Raspberry Pi is class 1. So we just have different variations of these that we're going to train our model on. So before we train our model, let's quickly log our profiles using YLogs and then write them up to YLabs. And we're going to use this as a baseline for our production data. So what we're going to do is we'll have this profile of our data, and we'll see what it looks like in a second. And then we'll be looking at the new data coming in when our model's in production, and then comparing that new data to this profile of our data, so we can tell that if something drastically changed, we can catch it very quickly. So what we're doing here is we're initializing the YLabs writer. We have the training path. Again, that's just to our training data set. And then we're just looping through all the images in that directory. And we're opening them with pill, which is a pillow. It's a common library for working for images in Python. And then here we're calling this profile log image. We're passing that image in and then making a profile of it. That profile is the YLogs profile, and we'll see what it looks like down here. And then we're basically looping through all those images and merging those profiles together. So we're getting some summary statistics about our images, and then just combining them into one profile, essentially, one value. So here, if we look at this next code cell, this is what that profile looks like. We have cardinality estimate. So again, it estimated there are 68 unique items. And in this case, there were, because we saw that there were 68 images. But if you had tabular data, again, it would say like, the cardinality of your data set. Maybe you have a lot of duplicated items in there, so you can kind of see how unique your data set is. If we scroll over, we'll see some other interesting metrics, like this brightness mean is pretty interesting. So this kind of tells us how bright all of our images were in our training data set, or at least the kind of combined maximum. The median, the mean, all those good values you might expect. And then you have different things like data types, which in here, we're just kind of logging these statistics as fractions, so they show up as fractions here. But this is also a good way to check your data. If you're using tabular data or something like that, and you want to make sure that there are no strings in it, you could also run a quick check with YLogs on your profile to make sure the data looks the way it does. And again, there's more documentation about how to work with image data down here. So now we'll come back to this when we get to the YLabs part, but just think of like, we looked at all of our image, we got these summary statistics of our full data set, and then we logged those up somewhere so we can use that profile later to compare against new data. So let's look at some data augmentations we can add to our images. So it's very common. They're going to kind of add what's called a data augmentation to your images when you're training your model. So you can see this is one image, but every time we read it in, it's varied slightly. And the way it's varied slightly here is we're just saying it can do a random flip or it can do a random small rotation. This just is a neat way of adding variation to your data set without having to collect, like, you know, this object could be rotated any different direction in there. We still want to do the correct classification. So we can actually set up these augmentations just to get these different variations of our data. And there's a whole bunch you can add. So go look at this documentation again if you're actually building a model and you want to make it a little bit more robust. There's a whole bunch of stuff you can add for like lighting conditions, add some noise in there and stuff. A lot of cool, neat stuff you can do. And then we'll just configure our data set for performance. So Keras has a thing called just auto tune, so it'll kind of look at the hardware you're running on and kind of to the best of its ability optimize for that. So now we're going to build our Resnet model. We're creating a function here. We're going to pass in input shapes, number of classes, and then something called weights. And again, we'll talk about this in a second, but that's where that transfer learning comes in that we mentioned during the slides. Also, no one mentioned this, but I don't know if you're watching on a small screen. Let me zoom in for you there. So here we're going to create a variable called Pretrain Model. We're going to read in from Keras something called Resnet 50, which is a really popular computer vision model for classification. And then we're going to say include top false. What this is going to do is we're going to read in that that architecture for this model, and it's a great one. It's very well performing for classification tasks. But because we want to use our own data today, we're essentially going to say don't include that last output layer, and we're going to add our own output layer and then train that to predict the data that we want. Then we're going to set input shapes. Again, that's going to be like that 180, 180 that we set earlier. Some other little metrics for classification, convolutional neural networks. But the important thing is we're looking at the number of classes. So today we're going to be just predicting 2, that Raspberry Pi and Jetson Nano, so it would be 2. And then we're loading in that ImageNet weight. So we can do the transfer learning. And transfer learning, like I mentioned before, is it's already trained on a whole bunch of different images. So it's actually really good already at picking up things like shapes and stuff like that. And then we just want to give it our own data so it can learn what colors and shapes make the classes that we're trying to predict today. So then we're just going to say most of the layers in the deep learning model are not trainable. We're just going to really be training the output layer in this case, but there's a whole bunch of different ways you could do this. And then here we're just going to be adding in our last layer of the model. And we're saying if the number of classes is 2, which it is today, we're going to have an activation function in the end called sigmoid. Basically, it's just a binary predictor. If you have more than one class or 2 classes you're trying to predict, you'll want to have a different output number. So it's just not just doing a binary prediction, but actually you could do multiple classes. And then so we're just now combining that output layer that we created on top of the rest of the ResNet. So again, if you're new to deep learning, that might sound really complicated, but it's okay. Run this code, and then we'll see what it looks like. So you can see it's downloading the weights for transfer learning. Then we're going to run this code here, which is going to plot out what our model looks like. So you can actually build these from scratch using like TensorFlow and PyTorch. Again, this is just a deep learning model architecture that works really well for a computer vision classification task. And we won't go through every cell here or anything like that. But basically what we did is we brought in this architecture that we know is going to work well. And then we chopped off this piece. Like when we said, don't return the head of it. It basically just didn't have this last layer. And then we got to build our custom last layer depending on what type of data we're predicting. So now that we have this model created, let's go ahead and train it. So I'll just go ahead and run this right now. And we're only going to do 3 epochs. That means we're going to look at all of our data basically 3 times and adjust weights in our model to try to predict those classes. There's something called a learning rate in deep learning where this is just kind of how your model learns, kind of how big to shift some gradients when it's learning. And then here we're going to kind of save the model at every epoch. So every time it looks at all the data, we'll save a version of that. And then here we're compiling our model. Again, you can pass in different things like loss functions. In this case, we are making predictions on binary model. So we're going to use binary cross-entropy, but you could change this out to be different if you have multiple classes. And then we're going to optimize for accuracy. So we're just going to look at the accuracy score mainly and optimize to get that higher. And then this .fit is actually where we train the model. So we passed in our training data set. We said how many epochs to train for. We gave it the callback, so it's going to save every epoch. And then validation data, we're passing our validation data set that we loaded. And this is what we get. So it's giving us some output here of accuracy. So we want this to go up. and you typically want your loss to go down. And we can see that it did, just for these 3 epochs. Accuracy went up on the training data set, and then the validation data set is pretty small, but it's still optimizing the loss function for it as well. So now we have our model. Let's go ahead and load it in. So I'm going to hit load model. And again, if you were to visually look at this, we can see that there's 3 TensorFlow models saved in our Colab notebook now. So let's go ahead and run our model on some images and see how it does. So here we are loading in an image. So this is one from the validation data set. It's a Raspberry Pi. We're doing a little bit of pre-processing on it. So basically we're just taking that image in, putting it into a format that the model can read it. And then here we're making our prediction, and we're just saying it's a Raspberry Pi if the score is a certain amount, and it's a Jetson Nano if the score is a certain amount. So here it's predicted that it's 99.57% sure it's a Raspberry Pi, and it is. And it was a, very marginally, maybe thinking it could have been a Jetson Nano, but very little bit. So let's go run it again with a different image. Same thing, and here it's 100% sure, very confident that this is a Jetson Nano, and it doesn't think it's a Raspberry Pi at all. So pretty cool. We went through, we gave it our own data set, we trained it again. I'll just quickly mention, if you're going to take your own data set with hopefully a lot more images, you'll most likely want to add a lot more epochs into your model as well. So it could be like 100 maybe to start with or something like that. It just really depends on how much data you have and variations and how well you want your model to perform. And then you're going to be looking at these values and kind of maybe even adjust hyperparameters like learning rate and stuff to get a better fit. So this works well for our example here, but just want to call out, these are things you often do in deep learning and machine learning called hyperparameter tuning. So you might want to come and adjust these things if you're using your own data set later. All right, so let's talk about monitoring them. So now we have our trained model. We're going to simulate us running this model in production for like 7 days or so. And we're going to loop through that days folder that we had, get all those images, make predictions on them, and then log those. So let's go ahead and run this code cell. And we can see we're just creating a dictionary up here for predictions and prediction outputs. And then we're going through into that day folder. We're initializing YLabs writer. So we're going to create logs over images like we saw before, pushes up to YLabs. And then we're going to loop through for day in the range. By default, if you were to just write a profile to YLabs, it'll use the date and time that it is when you write it. But we're going to overwrite that using we're going to get the date now, but then subtract a day for every time we loop through. And then we're opening the image like we did before. And then we're profiling the image with YLogs. We're calling that log image, passing it in, creating the profile, passing in the date time that we want the stamp to be at. And then we're calling writer.write. We're passing that profile, and this is where it's going to go to YLabs now. And then here we're making the prediction similar to like we did before on individual images. We're just looping through now and doing it, and then getting the score. If it's below 50, it's going to be a Jetson. If it's over, it's going to be a Raspberry Pi. And then we have a data frame that we just created here, and we'll look at this in a second. But so here's our output. We can see that it looped through all these days, and it's just giving us predictions for all of these images. Let's take a look in YLabs before we go further in the notebook. So I'm going to open up YLabs again. If I go to my home page here, I have my CV workshop one that I just created. I'm going to click into this. We can see we have some little bit of summary data here. This gets more interesting the more we add. So you can come back to this page later and you'll see some more data. Let's go look right now just to profiles. And we can see that there's profiles for all of those days that we just wrote up. But for our data today, let's go to this input tab and click on this image brightness mean. And we'll see now for all those days that we created profiles for, we have all this data that we subtracted just from our quick YLogs function. But you could also extract any data you want from images and then log that in a similar way. So YLogs is really customizable. You could even use something like object detection and extract just the colors in a bounding box or where the bounding box are located, as long as you can create some sort of value for it that can go in like a Python dictionary or a data frame. You can log it over time in YLabs. So here we're looking at the mean brightness for all of our profiles. And we see this first day, we'll just look at the median is like 189. The second day is 204. Not too big of a difference. You can see it goes up a little bit. And then this third day, though, it drastically drops. So the median's 107. Then this one goes back up to around the 180 range. And then this one's very low, 73. This one's low 100s. And then this one's really low, a median of 5. So that just looking at this visually, we can tell something's probably going on with our data, right? And we know we're looking at the mean brightness value for our data set. So if we had expected, like, this is a good range, which, again, we'll compare in a little bit with our profile that we created earlier on our training data set. But we can tell that this is a big change just in basically brightness value. So there's probably, in this case, something might be wrong with our images. So like we'll actually investigate this and find out what it is. But maybe someone turned off the light in the factory, like I was saying, and now all of a sudden the images are way darker. So this is cool. We can visually see this, but we don't always want to be manually checking every day or anything like that. So you might want to set up a monitor. So click that monitor button from the input page, or you can click this monitor tab. What we're going to do is set up a monitor on this data so that we don't have to manually come look at this. It can let us know when some sort of anomaly has occurred. So let's go ahead and click one of these presets. We're going to hit configure, though. So we're going to look for data drift. That's the input, the images in this case, the profiles we were just looking at. Let's hit configure. And then we have some options here to edit. Let's go ahead and change this value to 0.9. What this does is we use something called the Hellinger distance to calculate drift between the profiles. And this is making it, the lower the number, the more sensitive it's going to be, and the higher the number, the less sensitive it's going to be. So we're going to say 0.9 only trigger like an anomaly detection if the data changed quite a bit. So we'll see again what that drift value looks like when we run this monitor. And then here we have some options of like trailing window or reference profile. Trailing window is good if you don't have a good reference profile to compare and you just want to see over the course of 7 days or 90 days, did the data change drastically? You can use this. We're going to use a reference profile today. So this is our training data set, that aggregate kind of data frame that we looked at of the statistics in there. And we're going to be looking at that, the input data that we were just looking at, we're going to be comparing that to this profile. So I'll just also quickly mention, you can set up things like notifications over Slack or email. You can also set up an integration using something like PagerDuty here, where this could be when data drift occurs, you can kick off that automated annotation job I was talking about, building kind of an MLOps loop before. So a data drift might occur. You might have someone come in and annotate that data and then retrain a model. So now we have our monitor set. Let's go to this input tab. Let's go back to that image brightness mean. And let's preview this monitor. So you can see by default here, the monitors run daily. This one's going to run in about 6 hours. So all the data that we push up will get kind of clumped into one day, and then it'll run this monitor on it. So this should take a few seconds to preview here. And now we can see all these days that I kind of called out earlier where they shifted. These are all detected now as, probable data drift. And might be small if you zoom in, or you won't have to zoom in if you're following along, but just for the video, if you can't see it, you can see that now we have that drift distance calculated as well. So we did calculations based on this profile that we're looking at versus the training profile, the training data set, and said, it's quite a significant distance between the distributions in there. But these other ones, these are fine. The ones that we called out, like that didn't have that big of change. It's just these ones that are way darker got flagged that we might want to go look at them, and they don't match our training distribution. So chances are our model may not be performing very well on them as well. So let's go back to the notebook. I'll also ask, any questions so far? Was everyone able to follow along? Does this seem interesting? I think it's really cool how much you can do just by monitoring the input data. We're also going to go log the prediction outputs and performance, but just monitoring the input alone can often tell you when something's going on with your model, which is really cool. So definitely recommend always starting there, monitoring the data inputs, the model inputs and the model outputs will tell you a lot about your model in production. And then you can expand into other things like the explainability or segment your data where you can see if it's biased on any classes. So I'm going to go back to the notebook. Let's take a look at our data frame that we created. So here, this is a file name for each file in there. And then we had the predicted class for that file and the score, kind of the confidence that our model had for each of these days. So let's go ahead and log those predictions up. So this is now logging the outputs. And by default in YLabs, if you include the word output or outputs in your column name or dictionary key, it'll be logged to a different tab just to kind of separate it out from the input features. And I just want to mention, depending on how you want to set this up for your own models, you can log the, you might want to log the input and output at the same time in the same loop. I just kind of broke it apart for the workshop to make it a little bit easier. But in production, you might have something like this where, you're creating a single data dictionary of your inputs and outputs and then logging that at the same time. So here, now we've logged our output predictions. Close that tab. If we go to this output tab here, we now have predicted outputs, and this was logged as a possible quantile number because we were just logging zeros and ones. But if you actually had a class, it should come up as frequent items by default. But here, click on frequent items, and then we can see the predictions for every day. Those first 2 days that the data didn't drift. This is the distribution predictions. And this a lot can, again, tell you about your model. So this last day, if we were expecting to kind of always have some sort of distribution of 2 classes, and this last day has just 1 class, and that's when, if we looked at the input tab for the brightness, that's when it got really dark. It's, it went from a brightness value of around 200 to 5. So just knowing what this type of data is, we know that, well, probably the image got really dark here, and now it's just making a basically single prediction, a single class prediction. So we think, in this case, we can also see it's predicted class is 0, which was the Jetson Nano, which, if you remember, that's the darker colored one. So it's probably just seeing these dark pixels and they're just automatically classifying it as the Jetson Nano. We can also log the score here. So we can see on all those days where it got darker as well, our confidence was a lot lower. So the confidence on the other days is pretty high. Around 100, very close to it in the 99s. And then we get much more of a range on these darker pixeled images. So this also just tells us, data looked like it drifted and our model confidence is all over the place now where it wasn't on those other days. Something might be going on with our data. And let's go look real quick. If I go back to the slides, I actually have what these days of data look like. So here, this is the training data, so a small sample of it, right? We have this white background. This is about the brightness of these images. Let's go look at day 1. This is the one where it was still pretty confident and the data matches our training data set. You can see they're very similar, day 1 and 2. Definitely match our training data set. If we go to day 3, this looks way different. This is the camera zoomed in, maybe it fell down. There could have been some sort of schema change with the software and we didn't know that it zoomed way in now. And so if we again looked at the distribution of our input data, just for that brightness mean in this case, we can tell that something pretty drastically changed there. And that's probably because in this case, there's no more really white background here. It's basically just all a dark color or green. And this is day 4. So this is the one that was pretty similar to our training data set, didn't get flagged for data drift, but we can see that it is a little bit darker. And if we did look at the data, the median is down slightly, but not too much. But that's just capturing that it's a kind of this slightly different coloring background or lighting change. And then day 5, someone switched the mats out. So if we were, classifying these and all of our training data set had this white background, now all of a sudden everything has a black background, chances are our model, if it wasn't trained with that distribution of colors, it's going to not be performing as well. So again, if we looked at this, we can see, again, the brightness went way down. So we caught that, hey, something changed in your input data here. And then this is day 6, very similar. And then this is the day 7, that last profile where the brightness went basically down to 5. Our model definitely is not going to be performing as well on this. This looks really hard to make predictions, even for my eyes. I guess if you know how many of these little things the Pi has versus the Jetson, you could do it. But our model definitely wasn't trained on that data. It's trained on this data. So this is a complete change, and we definitely think our model's probably not going to be performing well on this. But let's go get the actual performance metrics and see. So this is where we're going to get the ground truth now and pass that in and compare, what was the accuracy of each day. So here I'm just looping through that data frame that we already had, and I'm just looking at the file name. If it contains a jet in there, it's going to have it as a class 0. If it contains a Pi, it's going to be a class 1. So now I can look at our data frame, and we see that we now have the ground truth on here as well. Oops, and I might have messed up somewhere. This should be fine, but you have an extra ground truth with a none type in it, which doesn't really do us any good, but it shouldn't do us any harm either. So here we're going to use the log classification metrics from YLabs. So we're initializing our writer again, and then we're passing in the specific columns we want to log. So we're going to pass in the ground truth and the class prediction output. And if you run this, again, it will loop through for each of the days like we've done before, but now log a performance metric. So then if we go to YLabs here and go to this performance tab, we'll see for each of these days now, we can actually look at the accuracy of the model. So again, we have a pretty small data set, so it might actually be doing okay, depending on how much the data changed. So actually on these days where it got pretty dark, it was actually still doing good. It was actually pretty accurate. But on this day where it got really dark, and you can see that on this one with the black mat, it did go down from basically 100 to 90, and then here on that really dark day, it's 50% accurate. That makes sense because it's just predicting one class. If you have 2 classes and they're the same amount, like if you had 5 of each, and if you're just always predicting Jetson, well, you're going to be 50% accurate. So it was always just making one prediction for a class, and we can see that it was no longer really accurate here. So we have all the kind of classic classification metrics logged here that you would want to look at: your precision, F1 score, etc., and confusion matrix. So now we've gone through, we've trained a model. We've learned how to look at the input data for, anomalies, in this case for like brightness or hue. You can see these other kind of image statistics that we pull. Hue is kind of the opposite, where it's darker and the line goes up in this case, but it's still also caught as an anomaly here because on these 3 days, it was very different than the other ones. So that's kind of a quick overview of how to build a computer vision model, but also monitor it in production. And I'll just share this link in the chat as well. I don't think it's in the YouTube description. If you want a certificate for attending the workshop, you can fill this out and we'll send you it in a few days or next week. And then there's also a lot of resources for you to continue learning. So again, we've gone through a lot, and depending on your experience, it may have felt super fast-paced, or maybe you don't understand something, which is totally fine. Just keep learning, and you can learn more at this cool intro for Keras. And obviously at YLabs, we have a lot of stuff on our GitHub as well as our blog. And then if you want to stay connected, please ask questions in the Slack channel. Does anyone have any questions right now before we wrap up the stream? And also, if you want to stay connected on LinkedIn, you can find me at Sage Elliott. I'll share the link here as well. Someone said, thank you. Thank you for attending. Thank you so much. And let me know, too, did you learn something new? Did you have fun? Was this interesting? Does it seem like a useful tool for you to at least know about? Does anyone have a story of like a model failing, maybe in production, and you weren't using monitoring for it, and you didn't realize it for a couple days? Someone said it was very interesting. Awesome. I hope you learned something new. And if you had never used ML monitoring before or really thought about it, you kind of know the tools now to start, building out, like we like to say, robust and responsible AI. And again, we didn't get to go into all the features today either. So if you want, you can learn more on YLabs.ai about segmentation and performance. And I'll quickly note as well, actually, is we have more events coming up. So there's one next week, which is going to be a little bit of a longer one. And this one I'm going to cover really all the important features around ML monitoring. It won't be on computer vision. It'll be on tabular data. So if this was your first time using YLabs or YLogs, it'll be a little bit different as well. But we're going to go through and cover some of the similar stuff that we did today, but on tabular data. But then we're also going to go into bias and explainability. So we're going to segment our data and see how it's performing on specific classes and really able to drill down and debug models that are in production. We'll also take a look a little bit more at YLogs and using some of the data quality validation features in there. So it's kind of neat. You can use YLogs, the library that you send data to YLabs with, to also do things like data quality validation in your Python environment. And while some people are still here, I'll share these links again as well. These are the survey links. So one, if you want to get some swag, fill this out for a chance to win some. And then also, if you want to try new features out around YLogs and YLabs, fill out the second form. We would definitely love some feedback on the new stuff that we're working on. I'll share this one more time in LinkedIn as well. And yeah, I see some people just joined too. We're going to be wrapping up the stream soon. All the links are in the description below, though, so you can always rewind this video, follow along, and pull everything out. Somebody asked an interesting question. How accurate are the statistics? Is there any error in the logged statistics introduced by the YLogs library? Well, if you're looking at things like the min, the max, etc., that should be pretty easy to calculate. The other quantile ones, I guess I'm not sure like what the error rate would be on it, but I could definitely ask our data scientists on it. It's also open source. You can go look at the source code if you want on YLogs. I'll share that link one more time as well. Any other questions from anyone? I'm just saving that question too, and I can follow up on it. Also, if you have any questions, again, ask them in the Slack channel later, and we'll get back to you. And there's other members of the team, like our data scientists and engineers too. So if you have any more data sciencey questions or ML engineering questions, it's going to be a good place for it. If there are no other questions right now, I am going to go ahead and wrap up the stream. So I want to say thank you so much for everyone attending, and special thank you for everyone who asked good questions and gave me feedback, especially for Alejandro letting me know that my mic wasn't working at the beginning. That would have been a very different stream if my mic stayed off. So thank you so much. And I'll wrap up the stream now. Everyone have a good day, and hopefully I'll talk to some of you later. Hopefully you'll have questions about this, and you'll maybe want to know about how to implement it in your own project. Let us know in the Slack channel. We're always happy to help you out. And with that, I'll talk to you all later. Have a good day.